everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students who has completed the course ROS Basics in 5 days. And at the end of this course, there is a project you can actually implement on a real robot in order to get one of our certificates of learning. So that's what we're going to be seeing here today from our student. So hello, how are you?
Hello, I am fine, thank you.
Great. I'm very excited to see your project. So please, whenever you want, start sharing your screen, and the floor is all yours. You can tell us how you've solved it.
Can you hear it? Can you see it already?
Yes, I can see your screen now.
So first I will show how it works.
Mm-hmm.
So it should start from the wall follower script that will first call for the find wall.
Uh-huh.
And now when it's running, it's trying to, it already find the wall, and now it's trying to rotate 90 degrees. So the wall following script may start. Yeah, it started. It also launched the odometry, so it started measuring how far it goes.
Uh-huh.
It should stop once it's in the same place, or roughly the same place.
Awesome.
Yeah, the robot looks mostly through its right and front cameras, so it can measure how far from the wall it is, and if there is like wall crossing, so it can make a turn.
Mm-hmm.
Yeah.
Cool.
I remember it's about 550 or something like that when it first cycle.
You mean the meters?
Yeah, the meters.
Uh-huh. So once it reaches a certain amount of meters.
No. It's actually stops basing on odometry, not
on the
by the meter.
odometry. Okay, cool. So it gets too close, and then I can see how it kind of gets away there. Awesome.
Yeah, there is like some threshold, so it's not wobbly all the time. And now it's posting the odometry.
Oh yeah, I see.
And yeah, and it stopped, and the job is complete.
Great, and it stops cleanly. That's awesome to see.
Yeah. So now how it was solved?
Great. Yes, please. Now that we've seen that, your project has been achieved, yes, please explain how you've solved it, basically.
So there are 3 scripts. The first one, it's I think about this one like a main one that calls the other 2.
Okay.
And at the beginning we have our subscribers and publishers, so we can see and command the robots to drive around. There is actions client initialization. I mean, we have it needs to wait for services to start, so it's wait for find wall and for odometry. Next we have dealing with defining the wall. It's about waiting for calling and then waiting for the response, so we know when the robot is positioned, when the robot is in position to start following the wall.
Right.
I go more in depth in this part, or
no, that's straightforward. As however you want to explain it, you explain it.
There is some if it wouldn't success, like actually currently it's always successes, but when I was starting, it was like finding the right way. So currently not all the script is used, or like it could be used, but succeeds. Here we just have some parameters that we use later in making sure that robots stay on the path, like distances and speed. Here we just updates the data from the laser. And this one is used later. And here we have like preparations for the wall following logic, so like calculations for our right and front indexes. I remember this one. So here we have our wall following logics. It's just like if. So we check if the front distance is smaller than our threshold, so one of the parameters set here. And we have like few ifs to like different, like as the distance is changing. So we have like approaching the wall, moving away from the wall, maintaining. Through this one happens quite rarely. Through it sometimes happens. This one we have for like when the odometry is completed, like so yeah, there is this while. So when the odometry says that it completed the cycle, we have this handler stop robot and stop robot. And so it changes the R to 1, so the while won't continue. We publish the... Oh.
Just give it a second. Maybe you need to refresh. Yeah.
So we just set the velocities to 0 and publish it.
Right.
It's handled by the empty response. So it handles when we actually completed the full cycle. And next we have the find wall. I mean, like next on the list, let's say. So
you have the service server, right? This is the service server now.
Yes. So in similar order, we have like publishers and subscribers first. Few parameters to set up that will be used later. Laser callback is exactly the same as the from wall follower. And this one will be called to turn left or right through, so it can actually find like the find wall logic is that it should like eventually spin to look for the wall through, because the parameters are set like they are, and the area is not that big that it usually finds it immediately, that it doesn't really have to look for it that long. We have our align with the wall part, where we're basing on the how much degree is the front camera and the shortest ray apart, how far are they apart. So first the robot will face the wall, and later it should take 90 degrees. Yeah, here. So when we'll go through here, yeah, it will angle to rotate. It will align with the wall. Detect the wall. Actually, I should start from here because, yeah, it's not in the perfect order. like it's called like it should, but
I'm sorry. Can you?
Yeah.
So, can you repeat that? The top part, the top function. What is it doing? It's doing. Oh, I'm sorry. No, I'm sorry. This
You mean
align
this
with
one?
wall. Oh. You have three functions: one to align with wall, one to go towards it, one to.
Yeah.
Okay. I see. Detect wall. You mean getting the shortest value, right? Your shortest one index, and then you turn towards that.
Yeah, we basing on the like distance. So the shortest distance through the wall, and then we also have like numbers of degrees. Other.
Can we move on to the odometry recorder now?
Yeah, sure.
Since for time's sake.
So odometry, it handles like the actually measuring the odometry, and later when the run is complete, this function is sending a message to stop the robot and the program, while the recording, it's like initialize the variables. Then we have the this one calculates the distance, how far are we going, and the one that publishes everything. And here is just log info, so we know how is total distance going, and we get it through the feedback. This is the lab complete. I am not sure how far deep into it I should go, or just mention
to make understandable what your program is doing, however deep you want it.
Okay. So
it sounds like you're done with your explanation.
Okay.
No, I'm asking.
Like, I think that I mentioned everything. If not, then I guess we will get to it. I forgot something.
Yeah, well, let's move on to my questions, because we were running out of time here. But first of all, I want to congratulate you. So really nice job, Miłosz. It's always really nice to see that as soon as you connect to the robot and run the program, it does it. That means there's been time invested into this, which is what we're looking for in order to get the experience of working with a real robot. So congratulations. I really liked, for example, you added some conditions. I noticed when you're finding the wall, you actually move back. It actually found it and then moved backwards, which means you added that condition in there. If you're too close, you're going to have to move back. Otherwise, it's not going to be able to do it. So, yes.
Like, I thought that it actually, like when on the test, there will be like conditions that, for example, it will be in the corner or it will be in the middle. So I thought that it will, I will try to make it always so it finds the way into the middle.
Yeah, exactly. Also, that's great. And now thinking forward, you might think of ways to detect either the wall or the obstacles, because if you're too close to an obstacle, it's going to think that's the wall, so it's going to turn towards it, right? Is that correct?
Well, it's not with the signs in the middle.
Yeah.
It not always works. Like, if it's too close, then it sometimes confuses it for the wall, because like, there was the ideas for it to detect the signs basing on like how much of the degree they take in the leader settings, like
yes,
how many rays there are. So when the robot goes too close, it's started to think that it's the wall because, I mean, I guess that there would be the setting that would work with it. If I would like try and try again, that I would eventually find the right parameters to set it, so it would detect if it's the sign or it's a wall.
Yeah.
But
It's just
I thought that
about robustness. I know this is not part of the project, right? You're not asked to detect between obstacles and the wall, but it's something you always have to consider in robotics, how to make it as robust as possible to catch all these scenarios. So I thought that was a good thing. So one thing I have a question is you had a service, an extra service, which was Stop Robot. Could you explain why that why what you're using that service for? I mean, I know it's for stopping the robot, but how it fits in there?
I mean, it come out from like first I wanted to put it in the odometry, like somewhere here, below this condition to stop the robot, but it's not always worked. So
you're not actually calling that service.
You mean like this one? Stop the robot?
No, if you go up all the way
more?
to the top. So you see there, stop service, line 21. That's a service server.
Yes, like, I mean, we call for it, but it's wait for a condition.
You have the handle stop robot, which is what triggers it, the callback. But who's calling this service, this stop robot? The odometry recorder?
Like, it's wait for this condition to happen, like here. So when this condition will trigger, we will get the empty message to our wall follower here. And now this condition will let the handler stop robot to do its thing. Like it will call for the stop robot, and this one will execute.
Okay. My suggestion here is you can go around this without adding an extra service server, because that's what you're doing in line 21. Mm-hmm. You're setting up a server that you can then call from a client. You would have to do, what you did for the wait for service and then call the service for the wall finding. My suggestion is to not introduce. I mean, you can, I guess, but you're not calling the service from a client. You don't create a client to then call that service. So, I mean, it's just unnecessary to create that service server. But if it accomplishes what you want, that's fine. Just keep that in mind, to not create either publishers that are not needed or subscribers that you don't need or service servers or action servers. And then the last question I have, Milos, is actually, no, it's not a question. It's something I noticed, and you talked about it, and I thought it was really nice. You have you kill the node when the wall is not found, right? You do like, all right, if this doesn't complete, you talked about, well, now it works, but sometimes it didn't. So I would just, it says wall not found, and then you did like a killing of the node of a ROS B somewhere in there. I can't find it. I can't see it. I think it's on your wall follow, and it says like wall not found. There it is. You see how else wall? So you're calling if you have a response, do this, and then if not, then you kill the wall follower. I think that's really nice, and you can build on top of this, because you can use the failure of your service not to kill your node, but to either try it again, like until it's 5 times. You're like, all right, something's going wrong, or you can do a little. All right, let's just move backwards a little bit, or whatever you want. And this goes in the lines of the robustness I was talking about.
Mhm.
because you already added that in. So my recommendation when you're doing these type of programs is to, when you have this, build on top of that. And it's like, all right, instead of doing that signal shutdown, I'm going to try 3 more times, and I'm going to do this and this and that. And then afterwards, all right, I'll kill it. So that's something I noticed that is really well implemented, and you can just do a whole nother program in there to see to handle failures, which is something that happens very often in robotics. So other than that, Milos, I really want to congratulate you again. Really nice project and really straightforward and very clearly explained. So thank you very much.
Thank you too.
All right, guys, let me move back here to me. And yes, guys, this is what you can do when you take our courses, our online courses, and you can get a certificate because we want to know that people actually took something from our courses. So you can do what Milos did here to present your knowledge and get a certificate from us. So I invite everyone that's watching to do the same. So thank you so much, Milos, and I hope to see you around for the next presentation.
Thank you again.
All right, guys. We'll see you guys next time, okay?